Hello everyone, in today's video we will be reviewing equations. So we will begin today by reviewing addition and subtraction, the easiest two. So we'll start with addition. Just a reminder that when you're doing equations, what you want, your main goal is to get x alone on one side of the equal sign. So for example, here it's not alone, it has this 6 with it. We want to get rid of this 6. How do we do that? Uh, Again, another reminder that an equal sign is like a scale. So whatever is on one side needs to also be on the other side. That means that I can also add things or take things away from the sides of the scale. But whatever I do to one side, I need to do to the other. So I can take this 6 away, right, by taking 6 away, right? It's the opposite of what is happening right now. We're adding 6, so if I do the opposite, I'm saying minus 6, I can take it away from this side, right? But if I take 6 away from this side, I also need to take 6 away from this side. I have seen this written uh, very nicely by people who like to do, okay, cross this out and then write minus 6 here, right? So then this becomes x equals 14 minus 6, right? So this becomes x equals 14 minus 6. And then 14 minus 6, that means that x is equal to 8. All right. Here, what's different about this case is that the x is after the plus sign, but addition is one of the operations where the order of the numbers does not matter. So 7 plus 6 is the same thing as saying x plus 7. Right? See what I did there? I just changed the order of the numbers, and it doesn't matter. It's addition, right? I can, if I want to, I can change the order of the numbers. So again, now I do the same thing. I cross it out on this side, and then I say minus 7 on the other side. Why minus 7? Because here it's plus 7, so here we do the opposite. So this becomes x equals 12 minus 7. And 12 minus 7 makes 5, so x equals 5. All right, but what do we do if the x is on the other side of the equal sign, right? Well, this is pretty much the same thing, but if it confuses you a little bit, you can, if you want to, change which, you can flip the equal sign around. So you can make 20 be on this side and then x plus 3 be on the other side, if it confuses you. Just the same way that saying, for example, 5 plus 2 equals 7 is the same thing as saying 7 equals 5 plus 2, right? We can do that, and that's allowed in mathematics, right? Well, the same way we can do that, we can also do this. And now this becomes a problem that we can solve again, right? We can take away the minus 3, bring it over to this side, cross it out, take it over to this side. This becomes minus 3, right? So x is equal to 20 minus 3. So x is equal to 17. Right. Next up, we can do the same thing again. And if you want, you don't have to. You can just say, okay, I need to subtract 5 from this side, and it'll be alone. But if you want to, if it's a little confusing, you can bring it over. You can flip what's on each side of the equal sign. You can flip one with the other. And again, if this is confusing as well, you can flip the x and the 5 in addition only. All right, so 5 plus x can be turned into x plus 5. Right? You can write it like this if you want to. Again, only in addition. And then we cross this out and it becomes minus 5. So we're left with x equals 18 minus 5, which means that x is equal to 13. Because 18 minus 5 makes 13. All right. What if we have more than one calculation going on? So here we have x plus 3 plus 4. Well, you have to ask yourself, can we do plus 3 plus 4? Well, yeah, sure we can. So we can do that first, right? And then we can continue with the rest of the things that we were doing. So if we were to say 3 plus 4, and be careful here because this plus 3 is very important, that it is plus 3. If this was negative 3, we wouldn't do 3 plus 3, and 3 plus 4 makes 7. So x minus 7. No, you have to take into account that this 3 is being subtracted. So it's like it's a negative number right now. You'd have to do minus 3 plus 4, which we showed how to do when we were doing negative numbers. You'll see that again. You'll see more of that next year, basically. So here we have x plus 3 plus 4 would make x plus 7, because plus 3 plus 4 makes 7. And this has to be equal to 25. And here, again, cross this out, make it minus 7, and we get that x is equal to 25 minus 7. So x is equal to 25 minus 7 makes 18. Here again, because it is addition, I can flip these around if I want to, right? So in the case of having the x between numbers, if it's addition, I can flip these around if I want to, right? So 8 plus x can become 8x plus 8. And now I'm in this case again, where we have plus 8 plus 9. Plus 8, because it's positive, plus 9 will make 17. And then 24 minus 7, I can also do this right now. 24 minus 7 makes also 17. So x plus 17 equals 17. So you might already be able to guess where this is going. So I delete 17 on this side, take it over to the other side as minus 17. So x is equal to 17 minus 17, which means that x is equal to 0. And if you want to, you could, if you want to, you could avoid this entire step entirely. You could do this calculation in your mind as it is right now. So 17 minus 17, 0. So you'd avoid an entire step, right? This wouldn't have to be rewritten. You could just do it like this, right? All right, next let's move into subtraction. In subtraction, I cannot flip the numbers like I can in addition. I can flip what's on this on each side of the equal sign. So I can take x minus 12 equals 38, and I can write it as 38 is equal to x minus 12. I can do that, just as I can write that 10 minus 3 is equal to 7. And I can also write that 7 is equal to 10 minus 3. But I cannot say that 10 minus 3 is the same thing as saying 3 minus 10. 3 minus 10 is minus 7. It is not the same thing. So I can flip these, what's on each side of the equal sign if I want to, but I cannot switch positions between the numbers that are on each side of the minus sign. So x minus 12 can't become 12 minus x, right? All right. So what were we doing before? We were doing the opposite of whatever the number was doing to both sides. So before we were at we were subtracting 6 from both sides, but now the number is being subtracted, which means that in order to make it leave this side, I would have to add 12, right? If I add 12 to this side, I can also add 12. I need to, it's not can. I need to also add 12 to this side. So minus 12 plus 12 would leave just 0. It would leave nothing here. And then plus 12 would go to this side. So x would be equal to 38 plus 12. And that means that x is equal to 50, because 38 plus 12 makes 50. Now, this is where things get a little more complicated. When the unknown is the number that is being subtracted, right? Now, if you remember what we said when we were doing equations, there is a little trick that you can use. And that trick is that you can trade the x with the number that's over here. So 48 minus x could be turned into 48 minus x equals 29 could be turned into 48 minus 29 equals x. Now, if you want a detailed description of why we did that, I am going to remind you that what we do is, when we do that, what we do is we simultaneously, that means at the same time, add x to both sides, which cancels out this minus x, but we also subtract 29 from both sides, which cancels out this 29. So the x's are canceled out over on this side, and the 29s are canceled out over on this side. And what's left is 48 minus 29 equals x, right? Because the only thing that's left on this side is this x, whereas on this side we have the 48, which remains unharmed, minus 29, right? Okay. Okay. So if you want, you can just remember this little trick. It comes in handy. And then 48 minus 29 is 17. Yep. Nope. Nope. It's actually 19. Sorry about that. So 19 is equal to x, or if I want to, I can write this as x equals 19, because we said that we can, if we want to, we can flip around what's on each side of the equation. So x is equal to 19 is the final answer. Now, what if the x is on this side and is being subtracted? Again, we can, if we want to, flip the sides on the equal sign. So 36 equals 50 minus x can become, if we wanted to, 50 minus x equals 36. Now, if we want to, we don't have to do that. We can do the same thing as what we did before, where we trade, basically, we switch places between this x and the number on the other side, so 36, right? So this would become x equals 50 minus 36. What we did there is we simultaneously added x to both sides and subtracted 36 from both sides. So the 36 got canceled out over on this side. We get minus 36 on this side, like so. And then we add x, so it cancels out with this minus x, and we get plus x over on this side. So x is equal to 50 minus 36. which means that x is equal to 14. Then we get this. 8 is equal to x minus 15. That's like this one, only the x is on this side. So again, if you want to, you can flip them around. You can bring the x minus 15 over on this side and the 8 over on that side of the equal sign, but it's not necessary. We could instead just say, okay, I'm just going to add 15 to both sides. Right? So this is going to become 8 plus 15 or 15 plus 8. It's the same thing. Equals x. And we can write x equals 23. See what I did just there is I simultaneously flipped the equation, right? I brought x to the left and 15 plus 8 to the right, and I simultaneously did 15 plus 8 equals 23. So x is equal to 23. Now, writing it like this is not necessary. Like if you wrote 23 is equal to x, no one would say that you're wrong. No one would say that you didn't solve it. It's just more of a, let's call it a tradition to have, when we give the answer, to have x on the left side. It's, what would we call it? Good practice, let's say. Okay, so here, this one is a little more confusing, and the reason for that is that there's a minus 6 here. This minus 6 ruins a lot of stuff, right? Now, we said before that if you have more than one multiplication, more than one calculations, you can do them before trying to involve x. So here, for example, we can do minus 6 minus 4 before we start doing anything with x. And we can do 8 minus 5 makes 3 before we do anything with x. But here, if you make the mistake of not noticing that this 6 has a minus sign in front of it, and you go and do 6 minus 4 makes 2, no, that's a mistake. I didn't mean to cancel the whole thing out. 8 minus 5 makes 3. And again, if you do 6 minus 4 here makes 2, that is a mistake. Why? Because this 6 is being subtracted, right? So what we're saying here is that I have a number and I'm subtracting 6 from it, and then I subtract another 4 from it. So how many have I subtracted overall? I have subtracted 10 overall, right? I didn't subtract 2 overall. If I subtract 6 and then I subtract another 4, I've subtracted a total of 10, right? Not 2. Now, that's something that you are going to get if you say, instead of 6 minus 4, if you say minus 6 minus 4. And this is from negative numbers. Minus 6 minus 4 would make minus 10. And here we have x minus 10 equals 3, which we can solve by doing x is equal to 3 plus 10. So x is equal to 13. All right, let's move on to the last one. Here we have 58 minus x minus 3. Now, this can get a little more confusing. So here, let's see what we can do. If you want to, you can do these one by one. So you could, if you wanted to. Instead of trying to do the calculations first, could say, okay, this is too confusing, so I'm going to take them out one by one. So I'm going to remove the 3 first, right? How would I do that? By adding 3 to both sides. So add 3. And this would become 58 minus x equals 36 plus 3, 39, right? And then we could solve this by flipping them. So switching x and 39. So this would become 58 minus 39 equals x, which would mean that x is equal to how much? Oh, 19 again, right? 19 again. Okay. Or if you didn't want to do it like that, and you wanted to first do the calculations, and this is perfectly fine. This solution is great. It is perfect. But if you wanted to, you could also do the calculations on this side first. You could, if you wanted to, switch the minus x with the minus 3. And that's because, let's say you have a number. Let's say you have subtraction, right? Let's say you have 20 minus 3 minus 4. So you have 20, and you're subtracting 3, and then you subtract another 4. Does it matter if you subtract the 3 first or the 4 first? No. So this 4 can, if we want it to, come in front of this 3, if we wanted it to. The same way, this could become 58 minus 3 minus x equals 36. And then 58 minus 3 would make 55 minus x equals 36. And then we would do the same switch again, where we trade places between the x and the 36, and this would become 55 minus 36 equals x. So x is equal to 19 again. This demands a lot more practice with negative numbers, which we will be doing next year. So that will be all for today. I will see you guys again in tomorrow's video when we'll be practicing multiplication and division in equations. Bye.